Assalamualaikum to our doctor. So we from group Ria Gen Z. So today we will be presenting on the topic of atomic absorption spectroscopy or AAS. This technique is widely used in analytical chemistry to determine the concentration of metal elements in various types of samples. In our presentation, we will explain the basic principles of AAS. We hope you find this presentation informative and beneficial. Thank you for your attention. Okay, so first of all, I want to explain about principal measure absorption of light by free metal ions. First, analytical techniques that measures the absorption of specific wavelengths of light by free ground state metal atom. When a sample is vaporized in a flame of graphite furnace, metal ions absorb light from a hollow cathode lamp specific to the metal by being analyzed. Amount of the light absorbed is proportional to the concentration of the metal in the sample. As you can see, this is about how it works, AAS. So AAS works for light source, atomizer, light absorption, and monochromator. And also be a detector and data detector.
For light source, a hollow cathode lamp HCl specific to the element being analyzed at the exact wavelengths that the target element can absorb. For atomizer, the sample is introduced into an atomizer, most commonly a flame or an electrothermal graphite furnace. This heats the sample, converting the metal compound into a gaseous cloud of free ground state atoms. For light absorption, analytical technique that measures the absorption of specific wavelengths of light by free ground state metal atom when a sample is vaporized in a flame of graphite furnace. Metal ions absorb light from a hollow cathode lamp specific to the metal being analyzed. Amount of light absorbed is proportional to the concentration of the metal in the sample.
Next, monochromator. A monochromator isolates the specific wavelength of light absorbed by the analyte, filtering out a detector measures the intensity of the light that passed through the sample without being absorbed. The difference between the initial light intensity and the measured intensity after passing through the sample is the amount of light absorbed. Data analysis. This absorbance value is then correlated to the concentration of the element in the sample, typically using a calibration curve created from measurement of non-concentration of the element.
Next is used for atomic absorption spectroscopy. For water, AAS can monitoring heavy metals in drinking waters, waterways, and environmental samples such as rivers, lakes, and ocean. For soil, AAS can analyzing metal contaminant and essential nutrients in agricultural and environmental soil sample. And next, for food, AAS can ensuring food safety by detecting toxic metal and determine essential mineral content, example leads, cadmium, and mercury. In biological sample aspect, AAS can analyzing metal level in blood, urine, hair, and tissues for clinical diagnostic, toxicology, and nutritional studies. For pharmaceutical, AAS can quantifying metal impurities and active metal component in drug product. While for mining and metallurgy, AAS can determining the concentration of precious metal and other elements in ores and alloy. That's all from us. Thank you. Last but not least is industrial application. AAS is used for quality control in various industrial for raw materials and finished products.